Okay, so we will make a recap and then we continue to build the model. So, do you have the model opened? If you don't have the model, you should open the folder containing the ResSim program. Double click on ResSim exe. And then open your model from File, Open Watershed. Okay. See, the color changes every time you open the model. So, the first thing we did was to make a shortcut from here, from Tools, the menu Tools, and then Options, and then Add Shortcut. We give a name to the folder. It means we build a folder, a directory, in which the simulation is located. So the first thing is to make this shortcut. Then, once we have the shortcut, we will build the model. We need to go to the watershed setup module, which is the first step of the model. Go to File, new watershed. Give it a name, select the shortcut here in select location, choose the units of measurement, the international system, and choose the time zone. Then we create the base map. To do this, we need to copy the shapefile inside this folder called maps. Every shapefile must have the same coordinate system. It can be WGS or UTM, it doesn't matter. What matters is that all the shapefiles should have the same coordinate system. Then we load the shapefile inside the model from here, View, Layers, Maps, Add Map Layer. And then we choose one shapefile at a time. We have to choose just the SHP file, not the other. And then, okay, for every shape we need. We can modify the view of these layers by double-clicking on the name. We can add labels, we can modify the fill and the border. We can also move, change level of the layer by clicking on the name and then on edit, move up, move down. Once we have the base map, we can draw the stream alignment with this tool, stream alignment tool, by holding on the control key and start drawing the river with the control key down. When we reach the last point of the river, we release the control key and click with the left button. Once we have the stream alignment, we draw the other elements, which are the control point, the computation point. These are points. These points are needed because they in this point there is we can see the input of the model and the output of the model. Then we add the reservoir with this tool, reservoir tool. We add the diversion with this tool. There are other elements. These are the levee, for example. If we don't want the river to overtop in some point, we can add the levee. We can add channel modification, other elements, but maybe another time if we have time. Okay. Do you have the watershed setup built and done and functioning? Okay, I think if you don't answer, it means that you have the watershed setup working. So let's go on. This is the study watershed setup, which is an overset containing all the elements of the network. But starting from this study configuration, see here, we can build some other configuration. We build the existing and the future configuration. To build a configuration, we go to watershed menu and configuration editor. From here, we create a simulation, a configuration from this menu, new configuration, and we modify the configuration, the element inside the configuration from the menu project and edit project list. We can add and remove project. So we have one existing configuration with the HEC Dam and Umera irrigation project, and we have a future configuration with HEC Dam and Umera Dam. Okay. Now we go to network. We already built a network. To open one network, you go to network menu. First of all, you go to reservoir network module, and then to network menu, open the existing network. What we did here is to draw the reaches using this tool, reach tool. To draw one reach, you just it is the same thing as when you draw the stream alignment. You click on the first point with the control key down, and then you click on the last point without the control key. When you create a network, HEC-ResSim import the element from the configuration to which it is linked. You can see here the existing network is linked to the existing configuration. So HEC-ResSim knows which are the elements you want to be inside this network, which are the dam and the irrigation diversion. So now we have to add physical and operational properties to the element. The element are the junction tool, the junctions, the red dot, the diversion, this black arrow, and the dam, this blue triangle. What we did in the 2 hours ago was to make some consideration about the junctions. For example, I will open Emba Madre junction. So with the right click and edit, we said that this junction has one inflow, which is called Emba Madre inflow, with a factor of 1. And we also said that in this junction there is one observed time series, the flow time series. And then we also said something about the reaches. For example, this one, the same, click on reaches or also on the selector here. Right click on the reach, edit. We just say that there is no routing. But if you have some data, you can choose between these methods and add the routing to the reaches. We said that there is no losses, and then there is no observed data. That is, the reaches are just the connection between an upstream element and a downstream element without any routing. Okay, and save. I think we were here. Yes. So, can I go further on? Do you have some questions? Okay. The reaches. Now let's talk about the diversions. So there is one diversion in our network. It is the Umer irrigation project. The diversion is an element and its function is this: to remove water from the system. Just this. We can sometimes the diversion can also give back part of the water it removes from the system. But to do this, we need to connect the downstream part of the diversion to the network. So what we do now is this: to modify this diversion in order to have the last part of the diversion connected to the river. Okay, so we will do this modification in the watershed setup module and then import the modification in the network module. So go back to the watershed setup module, to the study configuration, like this. Select watershed setup module, select study configuration, and you should be here. Oops. You should be here. Then select the diversion tool and double click on the diversion. You can zoom to see better. Okay. Can I go? I think so. Now we need to add some point inside the irrigation channel and then move the downstream part to make sure that the downstream part go back into the river. Okay, so holding down the control key, add 2 points inside the irrigation channel. Then if you select this black square and hold down the left button of the mouse, you can move the vertex. So if you move the vertex in order that the point is over one junction, HEC-ResSim asks you if you want that the Umera irrigation outflows is on the control point CP5. It is called in my network. So click yes. Okay. Now this irrigation diversion take water from the river in this point and release water to the river in this point. So save your watershed. Save watershed. And then let's update the network based on this watershed setup. To do this, go back to the reservoir network and then go to the network menu and update network from configuration. Yes, and you can see that the irrigation diversion is modified. Okay. Now we need to put some data inside, some physical data inside this diversion. Due consideration, the diversion have always priority. It means that if in the river here upstream the irrigation diversion, there are 100 cubic meters per second, and the irrigation diversion requires 200 cubic meters per second, all the water will be diverted into this channel. So have always the priority. Another consideration is this, that we can put some negative requirement. It means that diversion can be used as an input to the model. To see this, we go to the diversion tool, select the diversion tool, and right-click on the diversion and edit. Now we can, down there is a dialog, a new dialog, which is the diversion editor. You can see the name of the diversion. We have just one diversion, but if we add many diversions, we can choose between them by clicking on these buttons. In that first tab, in this first tab, we can choose a method to outdraw water from the system. Now it is a constant requirement, and we can say a requirement here, for example, 100 cubic meters per second. But we can choose between many methods. We will use the monthly varying method, or maybe the seasonal method. I have this value. You should copy the value and paste it into this editor in the folder called materials, elements, diversion. So go to the folder we shared with you 2 days ago, I think. Inside the folder called materials, there is a folder called elements and Excel files called diversion. Double click on diversion. And there is the water requirement. So this is the water requirement taken away from the river, outdrawn from the river. So we will copy this, we copy this, sorry, the column D, okay, the diverted water, into the diversion editor. So copy this column and paste the number here. I'm sorry, I have some, here it is. Okay. Here it is. Apply. And okay. Oh, no, not okay. So this is the water requirement, which is the diverted water column. Okay, you can use a similar value. You can also put, I don't know, 20 cubic meters per second for each month, or maybe you can just use a constant method. Is the same. The network will work in the same way. For example, if you want a constant diversion, we can write here 20 and then select every cells, right click, and then the fill and repeat fill. In that way, we have a constant withdrawal. Okay. I will use this anyway. Okay, apply. Then we need to say to the system, to the model, that part of the water come back to the system. We are going to say this here in losses. We choose return ratio, and we write here 0.15. We are saying that the 15% of this requirement come back to the system. We have also the possibility to choose a routing method, but we can go ahead and observe the data. I think this is enough, so apply and then OK. Just to be sure, save your work and open again the diversion to see if everything is okay. I think this is a bug because if you double click on the plot, you can see here that there is a cubic feet per second, but we clearly said that the model is in the international system. In fact, indeed, here there is a cubic meters per second. Okay. So close and okay. Okay, we have the diversion requirement. We have the return ratio. Now let's start with the reservoir, which is the main part of the training course. So we need to know a lot of things about the reservoir. We need to know physical properties and operations of the reservoir. We need to at least try to have some rule already done, and then modify it if we need to. We need to know the pool curves, the dam specification, the outlet specification, the power plants of the pumps, if there are, and on the diverted outlets, if there are. So let's start with the reservoir. We have one reservoir, it is called the HEC dam. You should select the reservoir tool and then select the reservoir HEC. Reservoir tool, you select the reservoir, right click, edit reservoir properties. There is the reservoir editor windows here. So what you see is this. There is a title bar containing the name of the reservoir, the menu bar. From this part of the editor, you can choose the reservoir. We have just one, so there is just one possibility. And you can choose the reservoir also with the navigation tool. Then we have the tree, sort of browser in which we can choose the part of the reservoir, the pool and the dam and other parts. And then we have the information part, the information panel. Okay, so for example, if we click on pool, we will see in this part of the screen the pool information. For example, we click on pool and the information panel will change to the pool curves. It is empty right now, but we need to fill it with some data. So please, now we need to open the Excel file called reservoirs. Okay, you see that there is the first page is the Kezedan. The first thing you see here is the pool curves, the elevation storage area curves. The units are already with the right units. So you just need to copy this value and paste into the editor. Copy. Then right click on the first cell and paste. Okay. Apply. And then you can see the curves here. Double click, you see the elevation storage and the elevation area curves. Okay. Okay, and save. There are many other things to add inside the reservoir editor, but save sometimes we need to save. So let's add the evaporation on the pool. right click on the dam, edit, and choose the pool of the dam. Right click on the pool and add the pool evaporation. The evaporation is set to 0 as a default, but we should copy this value and paste this value into the editor. Okay. There are some negative values here. These values are due to the precipitation. Okay, in these 2 months, precipitation is greater than evaporation, so the evaporation rate is negative. Should I wait for someone? Okay. In this slide, you can see the reservoir tree of the reservoir editor. There are just 2 elements inside this tree, the pool and the dam. Okay, this is a default for the system. All the other part that you see here is added by the user. So we need to add some part. The dam is made of a lot of outlets. So we have controlled outlets, uncontrolled outlet, power plant, pump. So what we do now is add information about the dam and the outlet. All the information we need are here in the Excel file. So the first thing we are going to say is that the dam is has an elevation at the top of 1,145 meters above sea level. And then we say that the top of the dam has a length of 420 meters. So let's copy this value, go to dam at stream 1 and copy this value here. 1,145 elevation. And then there is a length of 420 meters. And apply. Now we're going to add the power plant, the controlled outlet, and the uncontrolled outlet. Okay, so right click on the dam and add the power plant. Okay, the power plant has a lot of things to be controlled. So one of the things we must add is the number of gate. Let's say that there are just one gate, but we can modify this number. Here in this tab, we will add the maximum capacity for each elevation of the dam. So we copy this tab here. Inside this editor. It means that when the elevation is at this level, from the power plant there is an outflow of 220 cubic meters per second, and no more. This is the maximum capacity. Okay, let's change the tab. Let's say something about the power of this power plant. There is 300 megawatt of capacity. So it's 300 here. The overload factor is 0.6. Then let's say that there is an efficiency of 90%, constant efficiency, but there is also the possibility to set the efficiency based on the elevation or on the release, on the end. And apply. Another thing that is we need to save to allow the resim to make some energy. This to allow this dam to make some energy is the tailwater, because to compute the power we need to know the elevation, the difference in elevation. So right click on the power plant and add the tailwater elevation. You must say something about the tailwater elevation, otherwise resim doesn't produce energy. So here tailwater, see tailwater 972, constant elevation of 972. We can also, if we have some rating curve or some downstream control point with some known elevation, we can use this, but we just don't know. So let's say write this tailwater and apply. So if there is a flood now at this moment in this dam, the water cannot flow through the power plant or can overtop the dam when the level is over this level. We need to add some other outflow. We need to add a controlled outlet, which is the irrigation outlet, and a non-controlled outlet, which is the spillway. To do this, come back to the dam, right-click, and add controlled outlet. You can change the name of the controlled outlet by with the right-click and rename if you want. I will leave the name controlled outlet. So the control outlet is used as an irrigation outlet. In this example, it will have 4 gates with this capacity. So copy this number into the editor. And apply. There are some questions. Is everything okay? Now let's add the uncontrolled outlet, which is the spillway. So Select the dam, right-click, and add uncontrolled. In the Excel file, there are the specification of the uncontrolled outlet, which is aware with this crest elevation, with this wear coefficient, and with this length, 15 meters, and apply. Okay, let's check what is the capacity of this dam. To see this, select the dam, and then look at this table. In the first column, you have the elevation of the pool elevation. For example, let's take the last value. When the pool elevation is at 1,145, from the controlled outlet can pass 1,100 cubic meters per second. 220 from the power plant and the other 880 from the controlled outlet. From the uncontrolled outlet, from the spillway, can pass 335 cubic meters per second. This value of the uncontrolled outlet depends on the wear coefficient. If we change the wear coefficient, let's say, for example, 5, and then apply, this number will change. See that is higher now. So this wear coefficient is like a shape parameter of the wear. Let's let this parameter at 2. Oh. Okay, apply. Okay. Now save your work. And let's see if we did everything. So now we have the power plant, the spillway, some controlled outlet. We know the top of the dam. We know everything about the pool and the evaporation. We don't know nothing about the leakage of the reservoir, but you can add also some losses to the system from here. From the pool, right-click, add the pool seepage. If we have some data about the pool seepage, you can add it here. I will remove it because I don't know. Okay. Okay, we have the physical tab done. Okay, we are here. Okay, this is the most difficult part of the HEC-ResSim. That is the guide curve, the concept of the guide curve. So before start talking about the guide curve, I would ask you if you have some doubt. No. Okay. Okay. Now you should select the operation tabs. Your operation tab is empty. This is just an example. In the left zone, there is the zone rules 3. Inside this 3, we can choose between the pool zone and we can add the rules that function inside each zone. When you click on a rule on the left panel, in the main panel here, we will see how this rule works. So let's talk about the zones inside the reservoir. Okay. The reservoir operation is the act of storing water and releasing water. In the ResSim, this decision of store water or release water is taken based on two concepts, the guide curve operation and the operating zone. The guide curve operation is the process of determining releases, making releases in order to maintain the pool at the target elevation, which is this guide curve. It is called guide curve. So the guide curve is the desired pool elevation that we need to decide. We just can start with an hypothesis, with a number, and then modify it as needed. If the pool level is above the guide curve, the ResSim will decide to release water just to meet the guide curve. If the pool level is below the guide curve, then the ResSim will decide to store water to reach the guide curve. In this plot here, you can see the pool level for each month of the year. There are three levels by default in the ResSim. Just need to add it later, which are the inactive zone, the conservation zone, and the top of dam. Okay, so if the level of the pool reservoir after the calculation of the time step, the time step is below the guide curve, it is in the level A, for example, ResSim decide to close all the controlled outlet to allow the pool to raise to the guide curve. If the pool elevation is at B level, ResSim decide to open all the controlled outlet to reach as fast as it can the guide curve. This is the scope of the ResSim, to reach the guide curve. Okay, so the operation set, which is this part of the editor, is made by three parts. The zone editor, in which we decide these levels. The rules editor, in which we decide which are the rules that function in each level, and the allocation release, in which we decide the priority of the rules. So the first things to do is to make this operation set. Inside the operation set, we will add this information: zone, rules, and allocation release. Okay, so now you are here in the operation tab. You go to operation menu. You can write here, operation menu, new, and we gave a name to this operation set. Let's call it base. Every reservoir can have more than one operation set. Okay. Now we can add information about the flow control, the conservation, and the inactive zone. Let's start from the upper level, the flood control level. Okay, and then insert data from the up level to the down level. So here we have these cells with flood control, conservation, and inactive zone levels. Flood controls is set at 1144. The conservation is this, and the inactive is this. Okay, can I go? Do you have some doubt? No. Okay, now what we are saying to ResSim is this. We want that the Tekeze Dam, the Tekeze pool elevation is at this level. If the level is below this number, you should close all the outlet to come back to this elevation. This is the ResSim can work only with this information, but we can also add some rules. Yes. So now we are going to add the rules to the zone, to the zone. Yes. Let's add the hydropower schedule rule. It means that we have a power requirement, an energy requirement, which is megawatt hour, an energy requirement, and then we are going to say ResSim that this is our energy requirement. To do this, let's come back to the presentation. Okay, so we are going to build this energy demand rule. We right click on the conservation zone and add a new rule. And then we need to choose the type of rule. There is a lot of type of rule. This is an hydropower demand, so we will call it HP demand, hydropower. The release is from the power plant, and the type of release is a schedule. Okay, so let's do it. So right click on the conservation zone, add a new rule. The name is HP, I don't remember, demand. It releases from the power plant, and it is a hydropower schedule. There is a lot of type of rules from the power plant. In this case, we have a schedule. Okay. So for each month of the year, we need to insert energy demand. Copy the value here. And paste it into the editor. Okay, there is a more requirement during the summer, less during spring and autumn, and a lot of requirement also in winter. But we can make some modification because, for example, During the night, the energy requirement is lower. So we can say we can apply this reduction factor to the requirement to reduce the requirement during the night and during the non-working day. Okay. To do this, go to power generation pattern. Select each day. And apply this power reduction factor. So from 19 to 5 a.m. Just select every number of this table from 0 to 5. Right click and then fill. Multiply factor, for example, 0.2, because it is 1, 0.2. And then also from 19 to the end, fill and 0.2. And then also we should reduce the requirement during Sunday and Saturday. So we select this number during Saturday and Sunday. Right click and fill with 0.5. And OK. And apply. Okay. Now this rule is working just on the conservation zone. That is, if we leave the things as they are now, we are saying that if the pool level is here between the inactive level and the conservation level, in that case, you should use the hydropower outflow to make energy. If the level is upstream this level, the conservation zone, there is no energy production. So we will add the energy production also in the flood control zone. It means that we will add this rule here in the flood control. So right click on the flood control and use existing rules. Select hydropower demand, OK. We cannot add rules in the inactive zone, just in the conservation and flood control zone. Now we're going to add one irrigation requirement, both on the flood control and on the conservation zone. We can use this data in the same Excel file, this data from the irrigation rule. So now, as we did before, right click on the control on the conservation zone, new rule, That's called the ruled irrigation. Let's choose release from the controlled outlet, that is from the irrigation outlet, and let's select the release function, and then OK. So we stay here in the conservation. Add a new rule, irrigation, release from controlled outlet, release function. OK. Now we need to fill all this data. This is a seasonal pattern. We need to put manually this date and this number. So let's try to copy first, but I don't think it will work. Let's try. So first of all, define the type of function. We want it is that this is a release as a function of date. So function of date, define date, okay, and then try to copy the number. You cannot copy it. You must write it by hand. May. Now we will say that this is a minimum irrigation demand here. So the limit type is minimum. And then we can choose between the interpolation. This is linear interpolation. We can use cubic interpolation or step interpolation. Let's use a step interpolation because when we will see the result, it is more simpler to see how it works. So apply and add the same rule on the flood control. Right click on the flood control, use existing, select irrigation, OK. Apply. We can also add another rule, many rule we want. For example, there is an example here. We can choose to add this minimum flow release. Let's do it. So from the conservation, add a new rule. The name is minimum flow. It release this time from the HEC dam. It means that it doesn't the flow came from the power plant, the control outlet, or the uncontrolled outlet. It doesn't matter. What matters is that we have this minimum flow. So in the flow can be from every one of the outlets. And this is a release function type. And OK. Now we will try to change the function of. Okay, when we add the irrigation demand, we select the date. This time we go to model variable, and here you can see all the variable of the model. That is, this minimum flow can depend from all these variables, but we want to select the pool elevation. So we are going to select here the elevation. Okay, these are filters. It works as it was a DSS. So we filter on elevation and we choose elevation. Double click or one click and select. And then previous value. It means that ResSim check the elevation on the previous value of the dam. And if the previous value is 1095, then release 10 cubic meters per second. Okay, and let's copy this table here. And apply. Minimum flow, yes. We need to choose a specified here. And apply. There's no need to add this rule in the flood control. Because in the flood control, ResSim, first of all, want to release all the water from the zone to come back to the reservation pool elevation. So there's no need to say here we need a minimum flow. We need to say it in the conservation zone. And okay. Okay, save. File and save watershed. This is a list of all the possible rule types. There are a lot of types. For example, if we look at the controlled outlet, we can have a release function. We can have a flow rate of change. We can do some script with Jython. And if the release is from the reservoir, there are some other type of release and so on. This release, you say inside the yellow rectangle is the 3 releases we did. Hydropower demand, release function, the minimum release function, and the irrigation function. Okay, do you have some questions? Do you want me to share my ResSim project with you with a mail, with an email? Because if some of you cannot follow this training, maybe we can start with my project. We can continue working on my project. Okay. So I will send you a mail. I interrupt for a while the of sharing my screen. Ok. Gli mando una mail col file, se no qua, vero? Sono morti, mi sa. So I send you an email with with my model. Can you please tell me if you received this email?
Yes, it is received.
Okay, so if we want to follow the training course using this model, you can do it. I will wait a moment for you to open this model. You can put it inside the shortcut you did at the beginning of the training course. Maybe you can change the name if the name is the same. Sto mica condividendo, vero? Vabbè. Did you open the model? Can I go on? Okay. Okay, now I will open the model because I closed it. So, Sim. I'm selecting the network, open network existing, and here we are. Save. Okay, now we have the junction with all these with all the information we have. The reaches, we have the diversion, and we have the reservoir. We should have everything we need. Now, there's another thing I must say on the reservoir, about the reservoir, that is on the operation. Okay. That is this about this tab, release allocation. Okay. If we select release allocation, we can choose which one of the controlled outlet has the priority. It means I cannot choose because there is a bug in this 3.5 version of ResSim. We cannot choose between balanced or priority. If we use the 3.3 version, you can choose between balanced and priority, I think it is called. But there is another way to set the priority here in the zone rule. If you prefer that irrigation as the priority, you should put the irrigation as the first rule. So right click on the rule and move to top. In this way, when the pool elevation is in the control, the flood control zone, first of all, the water is released through the irrigation gates and then through the hydropower demand. You can choose which one of the priority you need to use for this particular reservoir. So in that simulation, we will give the priority to the hydropower demand. So increase priority. See, right click, increase priority. And apply. So to set a priority between the rules or to release allocation if you are using a previous version of the HEC-ResSim or just change the order of the rules here. Okay. I think that this reservoir is finished. Yes, there is another thing we can do, that is the observe the data. If we have time series of the pool elevation, we can add it here, or maybe the inflow or the evaporation, we can add it here just to, not as an inflow, but just to see the time series to calibrate the model. We don't have any of this, so let's let the tab as it is. I think that we finished with the HEC-ResSim. So close this tab and save. Okay. Then let's check the report menu, because as we see on the watershed module, also in the network module, we have this the possibility to see a list of all the elements. This is very useful when you will try to run the model and the model won't work. In that report, you will see the eventual, the error you did. So here you can go to reports, and then you can see the reservoir list. We have one reservoir. The most important is the network connectivity all element. In this table here, it is a little bit messy, but for each element, for example, for the junction called CP7, we can see what is the junction above, which is the junction below, and some other data that we need in the case we did. Okay. Okay. Save. Now we have the watershed setup. We have two configuration existing and future. We have the network. We have just one network. Maybe next week we will build the future network. Okay. And but we don't know nothing about the boundary condition and the initial condition. So now we are going to talk about the initial and boundary condition. This is the place in which HEC-ResSim sees the initial and boundary condition. It is called alternative. Each reservoir network can have more than one alternative. We will build just one alternative. So let's go to alternative, edit, and this dialog will open, which is called alternative editor. HEC-ResSim alternative editor. And in this editor, we set up the alternative. So go to the alternative menu here, and new. We will call it existing. It is linked with the existing network because we have just one network. The description is optional. And okay. Okay. We can add a lot of data here. So we can add data on the initial boundary condition for each reservoir, for each element. We can specify the time step of the simulation. We can specify the boundary condition, that is the inflow into the system, and the observed data. So let's start with the run control, with the first tab that is opened by default. In this tab, we choose the time step. We have our inflow data have a time step of 1 day. So let's choose 1 day because this is the time step of the inflow. And let the other point as they are. Okay. I just want to say that this compute unregulated flows allows the program to compute flow without the reservoirs. How it compute it is as the ResSim make two parallel computation, one with reservoir and the other without reservoir. If you want to keep it, keep it. If you don't want, just select this, unselect this. And then this program determined, it means that the ResSim choose in by default which is the type of the data. If the time step is greater than 2 hours, which we are in this case, then all the data inside the model is seen as a period average. If the time step is less than 2 hours, then it is seen as instantaneous values. Then that's it. Okay, let's go on. And now we are going to choose the operation. So move to the tab operation. In this tab, we just can choose the operation set of the HEC-ResSim. We have just one DAM with just one operation set, so it is simple. But if we did some more than one operation set in the HEC-ResSim, this is the place in which we can choose which one of the two. Then let's pass to the look back tab. The look back is the initial condition. We need to put some numbers here. We can change it later, but just let's have the same values. Non ho scritto. So let's say that the dam is at the conservation zone, initially at the conservation zone. So 1140. Now the pool elevation in the first time step is this. Okay, and then let's say that from every outlet there is a 0 outflow. Then the model will compute how much flow passed through these outlets, but for now it is 0. Okay, then let's pass to the time series tab. In this tab, we are going to add the inflow of the model. So please go to the folder called materials. There is a folder called inflow. In this folder, there is a DSS. We need to copy this DSS and paste it here inside the folder called shared. Okay. Now let's tell HEC-ResSim that the case left take the inflow from this DSS. To do this, select the first row and then click on select the DSS path. The DSS open. You already know how it works, so go to the open window, go to shared and to inflows. Because let's open this flow. Select this row and then set path name. And as you can see, the first row is now no more empty. So let's do the same for the other. Tekezaram takes from Atbara Tekeza, set path name, then select Emba Madre in flow, and then Emba Madre DSS, set path name, and then select Bordana and Bordana flow and set path name. And okay, plot. If you want to plot, you can plot this inflow. This is a link to the DSS. This is the same view of the DSS. The last thing is the observed data. So there is another tab called observed data. And we have our the hydrological gauging station. Okay. Before set the hydrological gauging station, I want to do these things. I want to change the name of these points because I can remember which one is Umera, which one is. So I will change the name And then I must do another thing. So now save the alternative, first of all, and close the alternative. I want to change the factor of these 2 points because I think I told you to set the factor to 1, but it is not 1, it is 0.5. Let's say that half of the inflow of this basin come from here, half comes from here. So let's change this number to 0.5 and also this. Because otherwise we will double the input in this dam. And save. Then this CP4, I want it to be called HEC because it is in the near to the HEC gouging station. So edit. I cannot change the name. Okay, now I must go to the reservoir, to the watershed setup. So let's go to the watershed setup. CP4 and rename. Here it is, HEC. Okay. And then this one is called Umera. Rename. Yeah. And this one is called Wadi. Rename Wadi Lidia. Okay. Okay, now we have the right name. Save. Go to the network, update from network configuration. So go to network and update from network configuration. Okay, we have the right name now. So it is simplest. Let's come back to the alternative and we have the almost all the right name. I forgot one. Don't know which one. Ah, okay. Umera was this, not this. Okay. So let's create this link. We need the DSS. We need the DSS that is here. Inside the folder materials, inside the folder observed flows. This is the DSS. Copy this DSS and paste it in the folder called shared. Okay. And now we did the thing we did before. It is we selected CP7, which is Umera. Select the DSS path. Open the right DSS. Observe the flow. This is Umera station set path name. And then do the same for the other 3 control points. Wadi Lilieu, Yecila, and Emba Madre. Close the DSS and save the alternative. We should have everything. Okay. So, do you have some questions? Save network, save watershed, save everything. We have the watershed setup and 2 configuration. We have the network, the existing network with 1 alternative, which is the existing alternative with everything we need, that is the initial condition and the boundary conditions. So the next step is to run the simulation, but I think we will run the simulation next week. Do you have some questions now, or should we try to run this simulation? Okay, we have 10 minutes. Okay, let's do a recap and let's run the simulation next time. Next on the 13th. Yes, on the 13th. So let's close off this file. In this last part of the day, we built the network, the existing network. First of all, we need to build from the network and new. In this dialog, we put the name of the network and we link the network with a configuration. Okay. When we open a new network, ResSim imports some elements from the watershed setup. ResSim imports just the elements without the reaches. So you will see the junctions, you will see the diversion, you will see the reservoir, but without anything that connect one to other element. So the first thing to do is to connect this element through the reaches. So we select the reach tool and then we connect one element to the downstream element. We work from upstream to downstream, always. So holding down the control key, select the first point, release the control key and select the last point. Once we have all the elements in the network, including the reaches, we can add physical properties and operational properties. Let's start from the junctions. So you select the junction tool, select one junction and right-click Edit Junction. This is the editor. In this editor, we can add some information. We can say that this junction is a local flow junction. It means that from this point, the the model, from this point, there is one inflow more. And then we can say that this point is also an observed, it is a gauging station. In this point, we have some observed data to be used as a calibration of the model. We can also add some rating curve, but we don't have it. So if you have, you can add it here. Then we need to add some information about the reaches. So select the reach tool, right-click on one reach and open the editor. From the reach editor, you can choose the routing. We select the null routing. It means that in one time step, the flow entering one reach is equal to the flow that is coming out from the downstream part of the reach. We can add some losses. We didn't. We can add some observed data in each one of the reach in the network. Then we add some information on the diversion. So select the diversion tool, right-click on the diversion, and then we can choose the outdraw method. We choose the monthly varying method. So for each month, we have one outdraw from the system. And given that this diversion is linked to the downstream control point, it means that there is some return flow. It means that from the upstream part, the systems lost water to put it inside this diversion, and in the downstream part, the system receives some water. So from the upstream part, this water is taken from the river. From the downstream end of the diversion, the 15% of the water is come back to the system. So through the losses tab, we selected the return ratio 0.15. It is a percentage. Okay, and then we add the dam information. First of all, we select the reservoir tool and then right-click on the dam and open the editor. The dam has physical data and operational data. This first tab is about the physical data. We add the pool curves, elevation storage area curves. We add the evaporation rate. In this way, right-click on the pool, add the pool evaporation. And then we add the physical capacity of the dam. In the dam, we put this number, that is the top of dam elevation and the length of the top of dam, and we add these three outlets. In this way, right-click on the dam, add power plant, add controlled outlet, and add uncontrolled outlet. For the power plant, we insert this information, the maximum capacities in terms of flow, the maximum capacity in terms of megawatt, the efficiency. Another information needed is the tailwater. To add the tailwater, right-click on the power plant and add the tailwater elevation. Then we add the controlled outlet. Then we say that this is for the irrigation demand. So from here, right click and add controlled outlet. And we insert all the maximum capacity for this outlet. And we also add an uncontrolled outlet, which is a weir, which is the spillway with this data. And then we talk about the operation, how the ResSim decided to release or store water. First of all, it decides to release or store water based on the zones, based on the pool elevation. If the pool elevation, this certain time step is below the conservation zone, this is the guide curve, okay? If the pool is below the guide curve, then ResSim close all the outlet to come back as fast as it can to the guide curve. If the pool elevation is up, is above the guide curve, then ResSim release as fast as it can, release water to come back to the guide curve. What we can choose is from which of the outlet we can release water. So we add some rules inside each zone of the reservoir. We add a demand, hydropower demand schedule. We add an irrigation requirement, and we add a minimum flow requirement. And this is all for this dam. And then we add the alternative. In the alternative, we just say this. We say that we have a time step of 1 day. We have the initial condition, and we have the boundary condition, which are DSS. It is a link to the DSS file. And this is all for today. So save your work, and then see you on next week. Do you have some questions?
Yes, thank you, Francisca. We appreciate your
Okay,
offer
thank
to
you.
simplify this process, although it is very detailed steps, but you made it straightforward. I encourage the participants to try it during this month until, I mean, week, until we will meet next Thursday at the same time. So thank you so much, and I'd like also to thank the participants for their patience and for their time. If you don't have any question, participant, I see someone is writing. Mamarath, Moses, I don't know. Yes, Moses, if it is possible to unmute yourself and deliver your message directly. Okay.
Okay. Okay.
Yeah.
We will do it.
Okay, good. Okay. Thank you, and see you
Thank
next
you.
week. Bye-bye.
Bye.
Yeah, please don't forget to fill the form for the participant, please.
Okay. Goodbye.
Goodbye.